All right, the first thing I wanted to do was clear up some confusion with Lesson 12. Lesson 12 deals with ratio tables and double number line diagrams. We're going to do the same problem. We're going to do it first with ratio tables and then with double number line diagrams, but in a little different way than I showed you in the last video. So the problem states that Kira is walking for a fundraiser walkathon. She walks 2 miles in 30 minutes. If she continues to walk at the same rate, determine how many minutes it's going to take her to walk 7 miles. So first things first, let's label our chart. I wanted to label miles and minutes. So that's the two things we're dealing with. All right, and again, she's walking 2 miles in 30 minutes. Now we can create a ratio table using our additive method. 2, 4, 6, 8, 10, and then 30, 60, 90, 120, and 150. Now, with the ratio table, what I've taught you to do is to figure out how do I get from miles to minutes? How do I get from the first row to the second row? And what you do is you identify a number that I can multiply by 2 to get me to 30, which is 15 in this case, because 2 times 15 is 30. So now that I found this constant, what I can do is I can determine any inputs to get an output. So I can figure out any miles to give me minutes. So I like to do this every time because sometimes it's not a nice perfect even number. Sometimes there'll be fractions or decimals. And we won't intuitively know the number that I have to multiply by to give me the minutes from the miles. So the rule of thumb is that we always take what's in the second column and we divide it by what's in the first column. So in this case, we do 30 divided by 2. And this time it's nice and even and it ends up being 15. So if I wanted to figure out what 7 was, okay, then I would multiply by 15. And if I go off over here to the side, because I can't do that one in my head, 7 times 5 is 35. 7 times 1 is 7, plus 3 more is 10, so 105. And it should make sense because 7 is between 6 and 8, and 105 is between 90 and 120. So if I were to stick that in the chart, I knew it's halfway between there. So in this case, I found a constant to solve the problem. But what about the double number line? So let's go over here. We're going to take the same problem. Now I'm going to draw a double number line diagram. So let's get ourselves a number line here. And like we said, we can think of the double number line like a diagram, like a ruler. And I'm going to want, okay, one of the sides has to be miles, and one is going to be minutes. So I'm going to do this. We have 2, 4, 6. Now I'm going to leave a gap just to give myself enough room here. 8, 10. On this side, we're going to do 30, 60, 90, 120, and 150. And because the miles and the minutes are correlated, they should come at the same spot. Now, let's do a different color here. We know that 7 is here. We want to know what is there. So the trick is to figure out what fraction away is 7 from 6. And this one is very easy to see, but the rule of thumb is you take the numbers on top, the interval that it's in, that we know it's in. It's between 6 and 8. There are 2 numbers between 6 and 8 because 8 minus 6 is 2. So that means 2 becomes our denominator. Okay, So we're looking for this distance right here. So 2 becomes our denominator, and then we say, how far away is 7 from 6? What's 1 unit? So this is a half of a unit because in here the units are 2, because we're going by 2's. So it's a half a unit, or 1, away from 6. We want to figure out how far away whatever corresponds with 7 is from 90. So here's where it gets a little confusing. We need to know how many spaces are there between 120 and 90. So you take 120, you take away 90, this becomes 12, this becomes 0, so this becomes 30, and that means that the space here that means that the space there is 1/2 of 30. And we got to figure out what is 1/2 of 30. Well, I could tell you that half of 30 is 15, but if we didn't know it, if it was a funny fraction, of just tells us to multiply. So 1/2 of 30 gives me 30 over 2, or 15. Now, does that mean that it corresponds with 15? No, because 15 would be down over here somewhere. So I know the answer isn't 15 because that doesn't make sense on our double number line, but I know that this gap here is 15. Well, it's 15 numbers away from 90. So then we take 90 and we add 15 and we will get 105, which is the exact same answer that we got on our previous page by doing the unit rate method. So this is finding the unit rate. It's 30 minutes for every 2 miles, or 15 minutes per mile. Again, 15 being the unit rate, 15 minutes per mile. And then this way we took a fraction. We found what fraction of the way over on the number line is it, and what fraction of the way over is the answer. Either way, we get the same exact answer. So if the double number line diagram is very confusing and you're really not understanding it, then using the unit rate method is a lot quicker and I think sometimes a little easier to understand.